So this is a additional lecture on alternating series and the ratio and the root test. I'm going to go over a couple of the problems from the homework. Here they are. So on page 648, exercise 77, what we're given is the following information. We have some sequence where A1 is equal to a half, and we're told that an plus 1 is determined by a simple rule from an minus 1, namely it is 4 times n minus 1 divided by, oops, that was weird. A sub n plus 1 is equal to 4 times n minus 1 divided by 3 times n plus 2 times the previous term an. And we want to know whether the infinite series converges. So the question is, does the infinite series that's the series, converge? And it's not an alternating series. We have two tests to determine if a series converges, the root test and the ratio test. In the root test, you take the nth root of the nth term. But we don't know the nth term. What we know is a recursion formula. We're given the nth term, this formula determines the n plus first term. But because of this formula, we see that the ratio of successive terms, an plus 1, divided by an, we know exactly what the ratio of successive terms is. And if we take the limit of the ratio of successive terms, we get 4/3. The theorem says that if this ratio converges to a number greater than 1, the series diverges. If it converges to something less than 1, it converges. Right? We should be taking the absolute value, but this is positive, so there's no need to. So the series diverges by the ratio test. Problem 79 is very similar. We have, again, a sequence of numbers, an, given recursively by a very simple function. And the ratio of successive terms, an plus 1 over an, is exactly equal to this. If you take the limit of this as n goes to infinity, you get 0. So this series converges by the ratio test. Problem 42 on page 639 is a problem about alternating series. So I should say For exercise 77, we're going to use the ratio test. For exercise 79, we're also going to use the ratio test. And in problem 42, we're looking at alternating series. So what we know about alternating series, this is a series of terms which in absolute value are positive, but they alternate plus, minus, and they are decreasing in absolute value. This is an alternating series, minus 1 to the n over something. So when n is 0, you get 1 over 2. When n is 1, you get minus 1 over 4. When n is 3, you get minus 1 over 8 times 6, and so on. So this is an alternating series. And okay. Yeah, let me get back to this. So this is an alternating series. And you know, if you take the sum after n terms, the difference between that partial sum and the limit is the n plus first term. So in this problem, we're looking at the series minus 1 to the n over 2 to the n times n factorial. What is the limit? What is the sum of the series? Well, Maple does it. It gives you the answer, 0.606 and so forth. How many terms do you need to have a partial sum which is within 0.001 of the limit? Right? We're going to use a graphing utility to do that. So this is the limit. We know from the theorem about alternating series that the difference between the limit and the partial sum is the n plus first term. When you put in capital N plus 1 into this and take the absolute value, this is what we get. So let's just actually, what I had done initially was I had looked at this error for n from 1 to 10. And I want to find the first point at which the error, the difference between the limit and the partial sum, is less than 0.001. And you see, when you let n equal 6, it's bigger than 0.001. When you let n equal 7, it's smaller. So just to focus on that. If I take the partial sum after 6 terms, this estimate isn't small enough. 7 terms is what I want. But suppose we really want to know the truth. This is just an estimate. What's the least number of terms you need so that the error between the limit and the partial sum is less than 0.0001? So for every n from, here I'm just doing it from 1 to 4. I'm looking at, this is the limit of the series. This is the infinite sum minus the partial sum, and I'm taking the absolute value. So this is telling me what is the error between the partial sum and the limit for different values of n. And when I do the calculation, this is what I get. 0.001, 3 terms is too big, 4 terms is fine. So by calculation, 4 terms is what you need. It's the smallest number of terms that gives you an error of less than 0.001. The theorem says 7 terms is enough, but which is correct, 7 terms is enough, but 4 is the minimum that you would need to take. And that is the story about those homework problems. And I will stop right there.